Okay, folks, we are going to kind of finish up Chapter 8 today, and what we're going to look at now is Section 8.7. So this has to do with absolute value equations and absolute value inequalities. So we need a couple of definitions here, and that is what I mean by the absolute value of something. So the absolute, let me fix this here so you can actually read it. Absolute value of an expression. Bad handwriting there. Let me fix this. So let's see. An expression. I think I've probably mentioned to you that I'm using a Microsoft Surface, so I have this special pen and I'm writing on glass, so it gets a little slippery and loopy sometimes. So the absolute value of an expression is its distance from 0. How far away it is from 0. So absolute value of an expression is its distance from 0. So for instance, if you were asked, well, what's the absolute value of 10? So you're saying, well, how many steps away from 0 is it? It's 10 steps away from 0. If I wanted to know, well, what's the absolute value of negative 17? It's 17. It's a distance. It's always going to be positive. If I wanted to know the absolute value of, negative 33, it's going to be 33. That's its distance from 0. So we want to kind of use this idea to solve an absolute value equation. So let's say, for example, if we wanted to solve something like this, say x plus 2 and absolute value is equal to 14. So what that means is this expression here, excuse me, this is 14 steps from 0. So when I take off the absolute value signs, which we're going to have to do, you got to realize that x plus 2 could be equal to 14, or x plus 2 could be equal to negative 14. It's 14 steps from 0. It could be on either side. So here, if I subtract 2, I'm going to get that x is 12. If I subtract 2 from this other equation, I'm going to end up with x is equal to negative 16. Now, let's check and see if this works. But again, keep in mind, this is absolute value. All right, so I would say if we're going to check this, could say the absolute value of 12 plus 2 is 14. So yes, absolute value of 14 is in fact 14. If I put in the other possible answer, which is negative 16, I get the absolute value of negative 14 is equal to 14, and yes, it is. So both of these solutions will work. Excuse me. All right, so let's try another one that's kind of similar to that. So if I said something like, see, 11 minus 2x and absolute value is equal to 20. So again, what's inside those absolute value signs is 20 steps from 0. So that means that either I have 11 minus 2x is 20. 11 minus 2x is equal to negative 20. All right, so if I subtract here, I wish I'd used a different number there than 20, but that's fine. I get negative 2x is equal to 9, or that x is equal to negative 9 halves. Over here, if I subtract 11, I end up with a negative 31 on the far right. And if I divide by negative 2, I get x is a positive 31 halves. Now, the thing that's nice about absolute value things here is these are both going to check. Not to worry, they will both check. All right, so what I wanted to do is let's take a look at our inequality handout here. We did the first, looks like 3 problems, but now we have this absolute value inequality. So what we want to do is to take this kind of like we did the other ones, and we're going to solve as an equation first. Solve it as an equation first. So that means the x minus 8 in absolute value is going to be equal to 19. So let's remove the absolute value sign. So that means x minus 8 could be 19, or that x minus 8 could be negative 19. Now, if I add 8 to both sides, I get an answer here of 27. And if I add 8 over here, I'm going to get a negative 11. So what we want to do, similar to what we did before, is I'm going to mark off these spots. So let's say if this is 27, and over here is negative 11. And we're going to test something in each interval. Now, just be careful. Remember, you have to take the absolute value of the expression. So, for example, over here, let's say if I test something like 30, something between negative 11 and positive 27. I know a bunch of you are going to pick, 0, which is fine. I'm going to pick something like 3. And then something less than negative 11, let's say if I said negative 15. So let's take these points, test them in there, see if we get a true or a false statement. So for example, if I had negative 15 minus 11 in absolute value, so I'd have the absolute value of negative 16 is greater than or equal to 19, which is true because the absolute value of negative 26 is in fact 26, so that's going to be true. All right, so now if I pick something in between these two values, so let's say if I selected 3, I have the absolute value of negative 5 is greater than or equal to 19, which is false. Absolute value of negative 5 is just 5. Now over here, I picked something larger than 27, so I picked 30. So if I have 30 minus 8, so I have the absolute value of 22 greater than or equal to 19, which happens to be true. So we want to kind of shade in where this is true. It's true here, and it's true here. Now the other thing is these were greater than or equals to, so that means we are going to include the endpoint, square bracket there. All right, so now when we go to write this in our interval notation, we have two separate intervals or two separate portions of the number line, so we will need two separate intervals. I want from negative infinity up to and including negative 11. I want positive 27, including that, onward to infinity. And anytime I have these two separate intervals, we're going to hook them together with that U, which stands for union. So the thing is, solve it as an equation first, and then kind of use this test point method here. All right, so let's try this one here. We're just gonna turn this over. So again, if I try to solve this as an equation to start with, so I have the absolute value of 2x plus 5 equals 21. So if I remove the absolute values, 2x plus 5 could be 21, or 2x plus 5 could be equal to negative 21. Let's subtract 5 here. That gives me 16, or x is 8. This one here, we are going to have 2x is equal to negative 26, or that x is equal to negative 13. Same method here. So I'm going to mark off 8. Here is negative 13. Remember, you want things in numerical order here. So let's see here. Kind of use some of our fancy colors here. All right, so again, we just want to select some value, doesn't matter what it is, within the interval and test it in the inequality. So let's say, for instance, if I had, let's go back to my pen here. Let's say if I had, say, x is 10. If I wanted to select something between negative 13 and 8, I know a bunch of you are going to use 0. Doesn't matter what you use. Let's say if I let x equal 5, that'll work. And let's say something less than negative 13, like negative 15. Okay, so let's see what happens here. I'm going to have the absolute value of 2 times negative 15 plus 5, and we want this to be less than 21. So inside my absolute value here, 2 times negative 15 is negative 30, plus 5 gives me negative 25. Now, is the absolute value of negative 25 less than 21? Because this absolute value here is 25. Is 25 less than 21? No, it's not. So that's false. Okay. All right, let's try the one here in the middle here. So I'm going to have the absolute value of 2 times 5 plus 5. So this is going to be the absolute value actually of 15, which is less than 21, which happens to be true. Now over here I have 2 times 10 plus 5. So my goodness, what is this? 25. So I ended up with 25 again. So absolute value of 25 less than 21. It's still not true. That's going to be false. So this is going to be true here in the middle. Now, because this is a plain less than, we do not include the endpoint. So we are going to have parentheses here. Now, we want to take what's written on our little number line here and write that as an interval. So I'd have negative 13 to 8, not including the endpoints. Okay. All right, so let's see here. Do we want to do the one with the fractions? Because I know you folks are going to run away from that one. So let's just do it. All right, so again, let's treat this as an equation first. All right, so I'm going to say the absolute value of 3/4 minus 2x is less than 1/2. So when I remove the absolute value notation, we're going to say 3/4 minus 2x is equal to 1/2, or 3/4 minus 2x is equal to a negative 1/2. Now, probably the easiest thing to do here is to clear out those denominators. So let's say if I take this equation here, our least common denominator is going to be 4. So if I multiplied through here, I would have 3 minus 8x is equal to 4, because the 4's will cancel there. And I made a mistake here. That's not equal to 4. That's equal to 2. That would be much better. 4 times 1/2 is 2. Now, let's subtract the 3. So I have negative 8x is equal to negative 1, or that x is equal to a positive 1/8. Please be careful with your signs. Now, likewise over here, if I multiply by 4, all right, so what we're going to do is, again, we're going to distribute this 4. So this is going to give me 3 minus 8x is equal to negative 2. Let's subtract 3 from both sides, so I'd end up with a negative 5. And if we divide both sides here by negative 8, we get x is a positive 5/8. All right, so let's put things on our number line. Don't freak out just because we have some fractions here. We're going to use a 1/8. We're going to use a 5/8. Now, the other thing is you want to remember that you need to pick something within each interval. It can be anything in there, anything to make your life a whole lot easier. Okay, so for instance, if I wanted to test something that was less than 1/8, in this case here, let's go with 0. All right. Likewise, if you pick something in between these two, between 1/8 and 5/8, the other thing I would look out for is maybe a little cancellation action in here. Something, so you want to do pick a number where you get some cancellation here. So for instance, between 1/8 and 5/8 is 4/8, which is the same thing as 1/2, and we'll get some nice cancellation action with that too. Likewise, I want something bigger than 5/8. Doesn't matter to me. You know, not x equals 2. My goodness, what am I thinking? 2/8, or excuse me, 4/8 or 1/2. Yeah. All right, and then after that, any number bigger than 5/8, let's say if we go with x is equal to 1. All right, don't worry about the fractions, we'll be just fine. So here I'm going to have the absolute value of 3/4 minus 2 times 0 is less than 1/2. So I have the absolute value of 3/4 is less than 1/2. 3/4 is actually larger than 1/2, so this is going to be false. Okay, now here in the middle, I'm going to have 3/4 minus 2 times 1/2 is less than 1/2. Okay, so these 2's are going to cancel out, so that I'm going to have 3/4 minus 1, or that this is the absolute value of a negative 1/4 is less than 1/2. So absolute value of a negative 1/4 happens to be a fourth that is less than 1/2. This is going to be true. All right, now in the far right section here, so we're going to have 3/4 minus 2 times 1. So 3/4 minus 2 is a negative 5/4, or if you want it as a decimal, a negative 1.25. But if you take the absolute value of negative 1.25, you get a positive 1.25, which is not less than 1/2. This is going to be false. So this one here is going to be true here in the middle. Now, to determine whether you include or not include the endpoints, you need to look at the original problem here. These are plain less thans, so that means the endpoints are not included. So we are going to use parentheses here. So when I go to write my answer in interval notation, parenthesis, 1/8, comma, 5/8. That's it. All right, so let's try, I think there's just one more here, is that right? Yep. So this one here, again, let's try this as an equation first. So I have the absolute value of 12 minus 4x is equal to 72. All right, so when I remove the absolute value signs, I have 12 minus 4x equals 72, or that 12 minus 4x is equal to negative 72. So if I subtract 12 here, I get 4x is equal to 60. And if we divide by negative 4, I get x is equal to negative 15. All right, over here, if I subtract 12, I have negative 4x is equal to negative 84. And if I divide by negative 4 here, I get x is equal to a positive 21. So I'm going to put the 21 here. Let's say if I have negative 15 here, and let's kind of divide this up here and pick some values that fall within these intervals, any number that falls within the interval. So something bigger than, let's say 21, let's say if I let x equal 30. Something between negative 15 and positive 21, you're all going to pick 0. I'm going to pick 6. And then something less than negative 15, let's say if I selected negative 20. All right, so let's put this in here and see what happens. So I'm going to have the absolute value of 12 minus 4 times negative 20 is greater than 72. So this is 12, negative 4 times negative 20 happens to be 80. So I have the absolute value of 92 is greater than 72, which is, in fact, true. All right, so now let's say if we move over to the middle, I'm going to have 12 minus 4 times 6 is greater than 72. So this is going to be 12 minus 24, or the absolute value of negative 12 is greater than 72. So if you take the absolute value of negative 12, you're just going to get 12. That is definitely not larger than 72. This is going to be false here. And now over here on the end, I have 12 minus 4 times 30. So this is 12 minus 120. Or my goodness, what is that? Negative 108, and absolute value is greater than 72. Well, think about it. If you were going to take the absolute value of 108, excuse me, a negative 108, it turns out to be 108. That's bigger than 72. This is going to be true. So now if we mark this on our number line here, here and here. All right, sorry about that. And let's see here, it's going to go there. It's some stupid toll-free number, get them all. And here, we're not including the endpoints because this is a plain greater than. So two different parts of the number line, I get two different intervals. So I'm going to have from negative infinity to negative 15, endpoint, parenthesis, 21 to infinity. And again, two separate intervals gets hooked together with a union symbol. Okay, now I wanted to look at one other kind of thing here. And the reason I wanted to look at this is because it is kind of the more advanced version of an absolute value problem. So for instance, let's say if I was just going to draw some, my x and y axes here. Okay. Now let's say if I wanted to kind of graph something here. Alrighty. Okay. So let's see. What I have here is some function f of x is equal to the absolute value of x minus 2. All right. Okay, so that is f of x equals x minus 2. Now I'm going to put something else in here. And that is, let's see here. Well, let me just do one thing here. I want to extend this just a little bit. And this one here just a little bit. All right, so the other thing I'm going to graph here is 2, 4, 6. I kind of doubled the scale, is this thing right here. So what I have here in green, I'll kind of color code this. G of x is equal to 6. So kind of that dotted line there is g of x is equal to 6. Now, my points of intersection are going to turn out to be at negative 4, 6, and positive 8, 6. All right. Now, there's a couple problems like this in your book. So, let's say, first of all, if you wanted to know, let's say if we wanted to know where are these two functions equal? So that is where does f of x equal g of x? Where are they exactly equal? So if you're looking at my lovely little picture here, where these two things are equal are going to be exactly here at our points of intersection. This is going to be true at x equals 8 and at x equals negative 4. So if you're trying to figure out where are these two things equal, it's going to be x equals 8, x equals negative 4. So let's say if we kind of write ourselves a note there here, you're looking for points of intersection. Where do they cross one another? All right. Now, same lovely picture here. And let's see if I wanted to know where is f of x less than or equal to g of x. Where is that function f of x less than g of x? Now, this is a little bit different here. One of the things you want to be kind of careful of is, or one of the things you want to keep in mind is when you answer something like this second question here, you must answer in terms of x. And the reason for that is that when you're looking at a function, and if it's a function, definitely a function, your x values are never repeated. Your y values could be, because even just looking at this one here, this thing that I have kind of graphed here in this dark plum color, well, this point here and this point here has the same y value. This one here, same y value, but my x values don't get repeated. So if we're trying to figure out, well, where is that true? When you're looking at your graph, we want to know where is f less than or equal to g. Kind of thinking geometrically, ask yourself, where is f of x below the graph of g of x? Below it. So since f is this big V thing here, and g is the horizontal line, it looks to me as though f is less than g down here. That's where it's going to be true. And as I said, we're going to answer this in terms of x. So my x value over here up to whatever my x value is over there. So I'm going to say for the second question here, -4 to +8. Now this was a less than or equal to g of x. The endpoints are included. Okay. All right. One more here, and you can probably guess what it is. Let's say if we wanted to know where is f of x, let's say greater than g of x. Again, have to answer in terms of x. So another way of looking at this or thinking about this is that f is above g. And this one here, f is below g. Okay, so if we look at my lovely picture here, f of x is going to be above g of x over here and over here. The f is above g. So again, we want to answer this question, but it has to be answered in terms of x. So if you're over on this far right side, this is going to be from 8 onward. This is going to be everything before -4. Before -4. So the way that I would answer this last one here is, this is going to be true from, let's say, -∞ to -4, parenthesis, because it's plain greater than, and then from 8 to infinity. Two separate parts of the graph, we have two separate intervals. So I know there's a couple problems like this in your book. This is kind of a tough one here. Not super tough, but you have to think a little bit. For those of you who have plans of going on to college algebra, this is definitely a college algebra type approach to this type of problem. All right, so I wanted to do like 2 more problems here that I know pop up in your book. They are absolute value equations. So let's just do 2 more. So I'll actually, maybe 3. I lied. So for instance, let's say if I had something, I'll do an easy one. Let's say if I said the x plus 7 in absolute value -4 is equal to 19. When you take off the absolute value signs, or before you take off the absolute value sign, what you want to do is to isolate that absolute value. So that is, I would say, the absolute value of x minus 7 is equal to 23. You want to do that first. Then take off your absolute value signs. This was a plus 7, my mistake. All right, so I'm going to have x plus 7 is equal to 23, or that x plus 7 is equal to negative 23. So if I subtract 7 there, I get 16. Here I'm going to have, my goodness, what is that? That is going to be a negative 30. Okay, well, let's check our answers here. Go back to our original equation. Whoops, there it is. All right, there's my abbreviation for check. So I'm going to have the absolute value of 16 plus 7 minus 4. So this is the absolute value of 23 minus 4 is equal to 19. And yes, in fact, it is. Now over here, I'm going to have negative 30 plus 7, take the absolute value, minus 4 equals 19. This is the absolute value of negative 23. So this is 23 minus 4 equals 19. And yes, in fact, that works as well. All right, so the other type of problem that's in your book here on absolute values, and this one, there's only a handful of them, is let's say if I had something like this, say the absolute value of 2x plus 11 is equal to the absolute value of x minus 9. So what you want to keep in mind is if the absolute value of two things is equal, what that means is that these expressions are the same distance from 0. Same distance from 0. So kind of get a picture in your head. If they're the same distance from 0, what that's going to tell you is that they're either exactly equal to one another, excuse me, or the other possibility is that they're the same distance from 0, but on opposite sides. All right? So when we remove those absolute value signs, what I'm saying here is that either 2x plus 11 is exactly equal to x minus 9. Or the other possibility is that 2x plus 11 is equal to the opposite of x minus 9. All right, it doesn't matter which side you deem the opposite, you'll get the same place in the end, so just be a little careful. All right, so here if I subtract x, and then if I subtract the 11, I get x is equal to negative 20. Here this is going to be, let's see, 2x plus 11 is equal to negative x and a plus 9. If I add x to both sides, I have 3x plus 11 is equal to 9. Subtract the 11, I get a negative 2, or that x is equal to a negative 2/3. Either one is exactly fine. Okay? But you just have to kind of keep in mind these things are the same distance from 0. All right, so let's do one more like that. All right, so if I had the absolute value of 2y plus 10 is equal to the absolute value of 15 minus y. All right, so again, they're either exactly equal or they're the same distance from 0, just on opposite sides. So keeping that in mind, I could say 2y plus 10 is equal to 15 minus y, or that 2y plus 10 is equal to the opposite of 15 minus y. All right, so okay, let's see here. Let's actually do something here. Let's say if I was to add y to both sides. So I would have 3y plus 10 is equal to 15. Let's subtract the 10. That leaves me with 5, or y is equal to 5/3. Over here, let's first of all, on that right side, distribute that negative sign. So that's going to be a negative 15 and a plus y. So if I subtract y now, I get y plus 10 is equal to negative 15. And if I subtract 10 from both sides, it looks like I got a negative 25. Both of these answers will work. Okay, so I know there's only a couple of those in your book, but I would definitely pay attention to those. All right, now, likewise, this guy here, I like this problem. When I say I like something, you might see it again sometime. You really might. Think about it. And the other thing is here, these absolute value inequalities. I don't know how to say this tactfully or nicely, so I'm not going to try. Do it my way, you'll probably get it right. Do it some way that you kind of sort of remember from the past, kind of half-baked, you're probably going to get it wrong. So I suggest you do it my way. It may take a second or two longer, but it's systematic and it works. So solve it as an equation, put those things on the number line, pick a number in each interval and test it in the original inequality and see where it actually turns out to be true. All right, take care.